Hello everybody, welcome to Advent of Code day 19. Today we will be solving the problem called Aplenty. So I already pre-read the description, so just to summarize it, we have a set of workflows that either accept or reject a part, and each workflow has a name, a unique name, that contains a list of rules through which our parts go through. And a part consists of 4 different attributes. One is X, M, N, A, and S. Together it's Xmas. So still back at the Christmas celebrations. So the workflows are defined as this kind of string where you have the name of the workflow, then curly braces, and then the rules that the workflow goes through. And the rules are evaluated from the left, and they tell you what to do with different values of different properties. So if X is greater than 10, we go to workflow number 1 with the name of 1. Then if M is less than 20, we go to 2. And A, if it's greater than 30, then we go to R. And if none of those apply, then we go to accept. And the initial rule is always called in, so that's the one where we start. So our input will look like this, where we have the list of workflows, and then we have the list of parts that we need to process. And the question is, how many parts are accepted out of this list? So let's get started on this problem. I will put the input here and start implementing it. So I will read a line, or maybe let's do it like this. So stream and get a reader. And now what I will do, I will first read the workflows, and I need to represent the workflow somehow. So I will have a record workflow, which will have a unique name and will have some rules. So there's something like this, whereas a rule, let's see how we can represent the rule. It has, what are options of a rule? Let's see, what are possible formats of a rule? It's greater than or less than, it seems. There is no equal sign, apparently. Yes, it seems that there is no equal sign, so it's greater or less than. So I will have let's see. We'll have, I need to have a record for the part as well, so let's start with that first. So a part will have a value for X, M, A, and S. So that's gonna be the values of that part. And then what I need to process it is always to know how to encode the rules. So maybe let's just maybe, the rule will be represented as part property. It's gonna be a car. This is the name of the property that we'll be evaluating. Then a boolean less than, and then long value. That's going to be the value we'll be comparing against. Then we need to have a private. It's going to be, oh, right, let's do it like this, static bool test rule of part against a rule, which will be, we'll get the value of the part, and then if it's less than, then we test this, and yeah, exactly what ChatGPT or GitHub Copilot generated for us. So that's good. We test the rule this way. Then we need a method, and the method will be, let's see, how do we evaluate this? And maybe string. It's gonna be process part, and we'll be going through the rules in the workflow and processing the parts. So so for maybe let's do it like this, that we put the method here, so we call it bool process, and we simplify the code this way. So maybe like this, that's gonna be better. Now we have a workflow where we have a process method again, which will go through the rules. So for each, and there should be always a final, or what is the syntax? I need to check that part. I see. This is like a fallback. So these are accepted, and this is a fallback rule. 4 rules. 1, 2, 3, 4. Okay. So string fallback. Return fallback. This is going to be the default, and now the rule needs to also have target, which is going to be where we should be going if the rule passes. So we process the part, which is going to be here, and when we process it, we will get a result. So let's make this public, of course. So it needs to be public, and this is going to be public as well. And now we process the part. So if the rule accepts the part, then we return rule target as a result. And if nothing passes, then we return fallback. So now what we do is we will while line string line equals reader read line. So while line not equals empty string. So right, I need to define here. So I will do line. This is going to be always not null. So if it's until we reach an empty line, we will do line split by this and do parts, and trim end by the closing curly brace, and then the name is going to be this, and the rules will be, we will be splitting by this commas, by commas. So we'll be splitting by commas, And for rules, not like that, I want just a for loop. For rules length, and I will go -1 instead, because the last rule is a fallback. So fallback equals rules -1, and finally, now we need to parse the rules. So parts, I will split it by first by the colon. Now the condition will split by we need to split it by a separator there. So yeah, multiple separators. So we'll split it by this and this. So we split it to get just the parts. So our property is going to be the condition, first part of the condition, and then we check if condition contains. Oh, actually, we can do it much more simply, because the name of the part will be like this. So rule parts, the condition is going to be this whole thing. So name. Oh, let's keep it. That's actually good. So condition 0. The first part of the condition is going to be the property. The sign will be index rule parts 0 index of greater than that equals true false, and then value is going to be exactly the value here. So rule will be new rule less than value rule parse 1. It's gonna be, yes, the second part of it after a colon. So that's the rule. Now we can create a list of rules that we add a rule to. And now that we have the list of rules, we can create a full workflow. So it's name, a rule list, and fallback all together. And finally, we need to have a list of workflows. And it's going to be a list of workflows where we add that workflow into, and then we process it for. So passing parts, it's going to be 0 initially, and for while we're not reaching null, while we're processing the file, we take the part, we parse it, and we need to check how that looks. So we need to trim start. Well, actually, it's going to be line substring of 1 line length -2. We just get rid of the 2 parts that we don't need. Then we split by comma, and then we parse it. So that should be okay, but we need to, okay, so we need to do substring by 2. We start at index 2 always. Okay, this way we should parse the part, and now we process it. And actually we need, instead of a list, we'll need a dictionary, it's better. So in the dictionary case, we'll have a string and a workflow, and we add name workflow to the list. So we have a quick way to reference specific workflows. And now for each part, so we start with current workflow. It's going to be the workflow in, and then we process. So while, and the name of the ending ones are R and A. So, well, true, let's do it like this. If next workflow name is A, we add to passing, and else if next workflow name is R, like rejected, we break, and then finally, otherwise we set it as the current workflow and continue. So that should be enough, I think. So now let's do console write line passing parts, and ideally this could work. So the result is 3, and that, where do we see the result? 3 parts, yes, that seems okay. So let's try the big input. And it's 79. Oh, that's not a right answer. Okay. Let's see. What did I miss here? There's actually a lot more parts. A lot more parts than I... Oh, do I consider the fallback correctly? So for all the rules, I process the rule, and if it fits... Well, let's see actually. If the value of the property is less than the value prescribed, then it's okay. If it's greater than this way, yes, this should be okay. So by processing the rule, I get either a the target of the rule, or the next rule in the list. And finally, I reach the fallback if everything else fails. So that seems to be okay. So if we reach A or R, then we stop processing, otherwise we go to the next one. It's all looking pretty good. So what is the problem? All right, I see. We need to add up the ratings for each accepted part. So that should be the result, not 79, but the sum of those values for those. So instead of this, I will need to have total, and that total will be equal to part X plus part M plus part A plus part S. So that might be better now. That just shows that you always need to properly read the problem description. 6,900, still a little bit too low here. And did I do equals? I did equals, of course. So Now that should be better. And now let's try this with the full input. That might be more like it. And that is correct. Okay, so that's the first part done. And now let's switch to the second one. All right, let's get to the second part of the problem. So in the second part of the problem, the issue is that we are no longer interested in the specific parts that are in the description, but we are interested in the big picture, where we are trying to figure out how many possible distinct combinations of X, M, A, and S values from 1 to 4000 are gonna be accepted, and how many are gonna be accepted. So all the possible combinations, and we are going to calculate the total number of them, and that's gonna be the output. So let's try to implement this version now. So I will take the original simple input. I will take the solution so far. And now let's try to figure out how to change it to accommodate for this new version. So now the part will no longer be just X, M, and A, and S. It's gonna be part intervals, and we are going to adjust it to use an interval type. And that interval type will be some new record, which we will call interval. And it's going to have int min max. And those are going to be both inclusive bounds. And one useful thing that can be beneficial is if we do length as well. So it's going to be minus plus 1 because it's inclusive. So it's going to be length of the interval. So we will have like the interval for each of the attributes. And then we have process to adjust the current implementation. So part intervals. Basically, this reading of individual parts is no longer relevant. So we have full interval. It's gonna be new part intervals from, and it's gonna be always 0 to 4000. So new interval 4000, not 0 but 1 to 4000. So this, and this. So this is gonna be our new input, and we will need to take the in workflow, which is going to be in workflow, and we start there and do workflow in workflow count accepted and full interval. So total count, and the total count will be the output of our app. And now we have a new count accepted method here, which is gonna be, we're just gonna count the number of accepted parts, number of possible accepted combinations of the intervals. And the processing will be kind of interesting because we need to do it recursively, and we will need to flow the accepted and not accepted intervals to the next rules to get processed, and from those finally get the total number of accepted combinations. So what I will do, I will just, the rule, maybe one more thing. The rule is kind of annoying. The annoying part here is that I'm not able to, I need to do something like this to access different attributes of a part. So maybe what I can do as well is to do public indexer for this. And it's gonna be this. Yes, exactly this. So it's gonna be, I will be getting, this will give me the interval for this, but I would like to have, or actually, can I do this? I think I can do this, yes. And set will do, we'll set those properties. Right, but I need to do it like this. So instead of this, I will do a case. So switch property, and can you generate this for me? Yes, thank you. So yeah, basically this. Although there is a problem that this is less accessible, so I'll have to do it as a public. And now that's better. So I'm now able to use the indexer on the part to index the intervals. Somehow I messed up this. So now have, yeah, missing closing bracket, and that should be better now. So let's see. Right. It's gonna be a record because we are now gonna be setting. Oh, right. I don't want to set this. Okay, I just gonna use it as read only, and we'll just create new part intervals when I need those. So this should be fine. All right. So now processing of a rule. Instead of a bool, we will be doing something like part intervals accepted, part intervals rejected. So we will be breaking down, the rule will be breaking down the input interval to two parts. One will be the list of the accepted interval, and one will be the rejected one. And what I will do is also make these, so I will take the property that's now gonna be easier using the part property, and we'll be comparing that Right, that's the problem. I see. If it's not settable, I still need to be able to create a new one with the same values except for a specific property. So yeah, exactly this basically. So with property of a given interval, and we will create a new one which has this specific property updated. So this should be fine. So now, I need to break it down to two intervals. So if less than, so if a rule accepts values that are less than, then I will take yeah, so it takes the minimum value of the interval to value -1, but no, we need to update the max. So the minimum of the interval stays the same, but the maximum is different. So max equals value -1, minimum of value max and value -1, and accepted will be this, and the rejected will be the maximum value, like like this new max +1 to max value that was input in the part. So this should be correct if I'm not mistaken. Although I see the interval is now using a long, I mean just ints, so I think it's enough to use int here. That should be just fine. So return accepted, rejected, and the same thing for else. So now we are using min of minimum value +1 and accepted, rejected. It should be hopefully fine. It seems symmetrical to this, so it should make sense this way. So this will be processing that interval and giving us 2 different intervals back. And I maybe will do one more thing. I will add a method empty, and I'll be checking if all the intervals are actually not empty, because when it's empty, it's no longer necessary to process it. So I will take the rule, process the part, and if it's non-empty, if the result is not empty, then I will check the target of the rule. So if rule target equals A, I will be counting the number of different combinations. So the combinations of X times combinations of M and A and S. So that's the result. And if it's not done, we will be continuing to the next workflow, which will be, no, not this, but workflows. What's the name of that? Workflows. Okay, so workflows with the name of target, and we'll be counting accepted and returning that thing. Oh, right, we need to count it locally as well. So actually, let's just this code to do this. Start with total accepted as 0. Then we do plus equals for the accepted ones. And then we do total accepted plus equals here. What is it complaining about? Why am I? All right, it's not a. So let's do dictionary string workflow static. Can I do static? So maybe it's gonna be easier this way. Or let's do it like this, just to have it still nicely top level. I will just pass in the workflows in that method. So dictionary string workflows. All right. So now we will use that dictionary to find that workflow, and that should be okay. So if it's accepted and the rule is the next rule is A, we accept, and otherwise we go to the next one. And if it's rejected, we continue with the next rule in the list, while we finally can reach the fallback. And if the fallback is actually kind of the next workflow we will be processing. So if fallback equals A, or basically it's basically the same thing as here. So maybe I will extract this as a method. So void process next workflow, and this is gonna be string next workflow. So if next workflow equals A, name, next workflow name. Yeah, so next workflow, and I'll put it here at the end. So process next workflow fallback. That's good. And now after we process it, we return total accepted. We always process everything, if I'm not mistaken, right? So we need to current intervals part. So we will be keeping that current intervals tracked. So we start with this, but the rejected ones go to the new instance of that will be rejected ones. So it will be continuing to the next one. Those rejected ones will be continuing to the next one. So basically keep this here. So let's do it like this. And if it's, oh, this is so wrong. I used is non-empty. It should be rather is empty, and the logic should be reversed. It's just hard to understand, hard to think about it this way. So less than equal, less than equal, less than equal, and less than equal here. So much better now. You just need to make sure that the references are correct. So if it's not empty, then we process the next one. If current intervals is not empty, if it's empty, then we break, and then the same check here. If it is empty, if it is not empty, I mean, then we will process. We will be processing the next one. So we'll be taking part and be processing that one. So that makes more sense now, I think. So now process next workflow will use the current intervals, and here instead of this whole thing, we'll be using process next workflow, and you use the accepted ones as the target. Okay, so hopefully this is now correct, and we shall see. We shall see if it works or more tweaks will be needed. So I'll start with the simple input. but there is some issue. Yes, it's actually int now. Yeah, of course, I forgot about rejected. I see. Else, if it's rejected, if the next workflow is rejected, we just end there. There's nothing else to do for the given part. And the result is a little bit low, so maybe long. Oh, right, I'm doing the wrong thing here. No, it's fine. Long and like this. The number is quite big, but yeah, it's not correct yet. So what can be the issue? So we're using the intervals we are given in the in yeah, okay. When we reach the accepted one, we need to calculate the number of ones that are accepted. That's fine. And if it's not there, we continue recursively into the next workflow, which is also okay. Just the question is, why the resulting number that we are getting is so high? So let's verify this part. So when we're checking if it's less than a given value, we are making sure that the value the max value is value -1 at most. And now the accepted part will be value am I checking for if it's not empty? Yes, I'm checking for that part. Yes. If it's not empty, yeah, okay. That's okay. That's working. So accepted ones will be part with that property going from the current minimum to the new max. And rejected ones will be going from the new max to the original max. Just verify this a little bit. So new max will be, so the value is 1351. So new max is 50. Value, the interval is there. So we basically have thousand 135. Yeah, it's fine. And now it should be this. Yeah, that's okay. That works. So for minimum, it's main value, and we're taking the max of that. So greater than and given value. So okay, we're going from the min to max, that's accepted part, and from original min to new minimum -1. Okay, that might be the problem here. I think we are. No, it's okay. It's okay. Yeah, that's okay. This new min. So this part seems to be okay. I don't see a problem here. So let's do a quick sanity check. And if we do in and a, this input should give us 4000 to the power of 4, which it doesn't seem to be doing. So why? Okay, let's verify. Put a breakpoint here. So there should be no rules, and so we're processing the input with, yeah, exactly. So the total should be, how does this happen? Oh, of course, because I'm, yeah, that's an important issue I was forgetting, because I'm overflowing the individual parts, it seems. Now, I should be getting much better numbers. So let's see if this will make more sense. Okay, that seems better. So I was, the multiplication there that I had here was counting with integers, and those integers by themselves were okay, but they were overflowing when multiplied. So as a result, I went into underflow, like in minus values, then to positive values, and the result was making nonsense. So now I'm converting to Yulong first, so I can multiply them safely without overflowing anywhere, and that's the crucial part. So let's see if it's gonna work with the big input. Okay, the result is smaller, but it is correct. All right, so that was a little bit tricky, making sure that you are staying within the bounds of the data type that you've chosen for the calculations. So definitely important thing to keep in mind. I think there is a way to, that is definitely a way to make sure that C# checks for this. I think if I remove this and do it like this and do checked, is it? Okay, not here, but maybe it can be used in this level, but here. So, right, that's important, right? It's a block thing. I've never used. I used it, but a long time ago. So maybe this is the proper syntax. Definitely is the proper syntax here. So when used like this, I should add a exception, overflow exception, that tells me that there's a problem happening and I should definitely take care of it. And that explains everything. So good to know. Good to know that this was not enough and we need the Yulong cast everywhere, and that will work. So that was a fun one. I hope it was useful for you. And I will be doing another video where ChatGPT will be solving the same problem. We'll see if this time it's gonna be able to solve it. It doesn't seem as complicated Even the description doesn't seem as complicated, so maybe it will be able to solve it, but we'll see. And in the meantime, keep coding. If you want to get notified, please subscribe, and I will see you in the next video. Bye bye.